Hello, and welcome to this installment of our video series with ASCO. I'm Amara Razgis with Consulting Specifying Engineer, and I'm happy to be here with you to discuss a variety of power and energy topics. Today, I'm speaking with Russell Senesac, who began his career with APC in 1996 and has held several positions in the past 25 years, including sales, product management, and strategy. His concentration has traditionally been in mission-critical applications, specifically with data centers and edge environments. Within the Schneider Electric portfolio, Russell has most recently been focused on market trends, disruptions, and collaborating with R&D teams to solve changes and challenges faced by the partner and end user communities. Just recently, Russell broadened his focus to include the rapidly developing new energy landscape, which includes electrical source management, distribution, and load prioritization. Hi, Russell. How are you today?
Good afternoon. How are you, Amara?
Excellent. Thank you. So let's jump right into this. There are a lot of changes that we're seeing in the electrical infrastructure here in North America. Our research shows that many engineers are now specifying systems that include generators, UPSs, and now battery energy storage systems. Can you help us understand some of the changes that we're seeing?
Sure. This is a classic Yogi Berra moment when you use the quote, "The future ain't what it used to be." So if you look traditionally, and you'll see it here in the data itself, we're very, very educated in the use of generators and transfer switches when it comes to providing emergency power. This was a study that we did with a consulting specifying engineer earlier this year to try to be able to understand a little bit about the market. And if you look at the market itself, for the most part, it's been dominated by those UPSs and generators and transfer switches, with the general idea that power goes out. We have two sources available to us. The one was the utility and one was the generator. So if the utility is out, transfer switch, UPS generator was what we used to be able to get us power restored. And that's been very tried. It's been very true. It's been very robust and resilient. But the future and changes are among us, because now with the advent of a lot of these sustainability initiatives, as well as just general advancements in technology, you see that fifth one or sixth one there on your list now, which is now the batteries and the inverters. And this is really something that we've seen now grow tremendously over the next couple of years. And depending upon which version of the future you want to believe it, it will continue to grow exponentially in the time to come. And so that'll be a lot of focus on what we're going to talk about today here. It's just about the what's driving that battery energy storage adoption and what does it mean for the marketplace.
Got it. Yeah. So we've traditionally viewed our electrical infrastructure as primary and emergency. But with what you're talking about, with the utility being primary and backup sources like generators or batteries being emergency, it seems like that's all changing. Can you give us some perspective on this trend and the advancement of other technologies?
Yeah, it's so this isn't George Jetson type of stuff, right? This is here and now, and only going to become even more prolific as we move forward in the future. So if you think about, I'll take this slide and almost work from the bottom up. It used to be very much the idea that the utility was the primary, and anything else that you had from an energy creation device like a generator or even UPSs or batteries was all the secondary. And there are buildings today that operate primarily on distributed energy resources. So people call them DERs. So those would be anything from fuel cells to solar, battery energy storage systems, even things like wind or compressed air or other types of energy generating systems. So it's very much moving much towards a era where that utility isn't necessarily considered primary. And I think that kind of changes a lot of perspectives, because if you look at what we just talked about in terms of source management with like power, the utility and the generator, if I go back to the top, the idea was I only had two sources and I just switched for resiliency. So power would go out, I'd switch my source. Now you have multiple sources So like we talked about, you could have anything from solar to generators, to fuel cells, to batteries, wind, etc., plus the utility. And now you no longer change necessarily for just resiliency. So you're not waiting for the power to go out to actually change that source of power. You might be changing that source of power based upon sustainability decisions, right? So if you're trying to become more green, there's tons of companies out there that have stated net neutral goals, sustainability goals, carbon-free goals. And the idea now is that you want to be able to draw from the most sustainable energy at any point in time. You're also going to be making decisions for energy sourcing based on cost. So if the middle of the day, the sun is high and you're making lots of solar energy, that's a very, very economical way to be able to power your building. So those decisions now become a lot more difficult in the sense that before it was either or. Now you've got kind of like the and statement of like, it needs to be resilient, which is expected, and it needs to provide sustainability, or provide lower cost, or provide something else. And so it becomes much more challenging in that idea of source management. Source management used to be two, now it's multiple, and we're changing for multiple reasons. The other piece of it is also now looking at the type of power that is coming into the system, right? So traditionally, a generator, a reciprocating engine, and the utility were alternating current, AC. And the loads that consumed the power, for the most part, were all DC. I've seen the AC, alternating current, as well. So that's your plug that everybody recognizes that you plug into the wall. So it was very homogeneous. Now, a lot of these distributed energy resources that are showing up, so solar or wind or batteries, fuel cells, etc., all natively produce direct current, so DC. And on the other end, on the loads, you're now starting to see proliferation of more DC-based loads, right? So LED lighting is probably one of the easiest ones for that. Everybody knows about how your regular bulb went from like 60 watts to 6 watts. So it's because it's being powered by DC now instead of AC. So there's huge efficiencies there. Another one people are going to relate to very easily is going to be your electric vehicle. So your standard level 2 charger today that charges on like a 50 amp breaker, but if you wanted to charge it, in a couple hours instead of overnight, you get a supercharger, fast charger, and that's a level 3. Now a level 3 typically works on DC, and so now you've got DC sources and now you've got DC loads. And so if you think about it today, our buildings for the most part are AC buildings with DC tendencies. So the DC is like subsystems inside those buildings. In the future, it's very possible now that the building and the sources become big enough in terms of like their total percentage of the system, now that the building could potentially become a DC-based building with AC tendencies. And that has big implications, obviously, in terms of how you wire it, how it operates, etc. So lastly, just because I talked about the EV, and this is going to be really easy to kind of understand, the power used to flow one way, right? It used to go from the top to the bottom, from the utility down to the load. Now you've got things like an electric vehicle, where that electrical vehicle during some instances will be a load. I have to charge my car, right? So it's a load. But there will be other scenarios, and I'm sure we've all seen like the Ford Lightning commercial or other commercials that are out there, where the power goes out, and if my EV is in the garage and it's fully charged, I could actually use my EV, my battery, and my EV to actually provide power to the house, to the building. And so if you can imagine a parking lot or a parking garage full of EV cars in the middle of the day that are all charged, that I don't need it to be able to drive somewhere, that could actually be considered a power source for buildings and whatnot that are in the surrounding area. So there's a very interesting and disruptive future when it comes to the directional flow of energy, right? So it no longer goes top to bottom. Sometimes it could go bottom to top in that scenario. And another easy one for people to understand too is the idea of net metering. So if I have solar and I have a battery energy storage system in my house, and it's the middle of the day and the sun is shining, and I no longer need all of the electricity that solar system is creating, I can actually sell that energy back to the grid, back to the utility. So again, that's another example of energy actually flowing up versus it only flowing down. So you take all those things and you kind of mush them all together from a source and energy management standpoint, and you realize that that we're heading off into a future that really doesn't look much like the past at all. And really, from a tectonic change, you haven't seen this kind of tectonic change in the electrical industry yet. I would argue you've seen it in the telecommunications industry when your rotary dial phone that was corded, that was plugged into the wall, became your iPhone, right? And your phone became, a movie theater or a taxi caller or a maps director, and all these things that your phone, that was plugged into the wall would have never been. We're headed into that same kind of tectonic shift now in this electrical infrastructure industry, where 10, 15, 20 years from now, you'd look back at it and you never know what it used to be, because it doesn't look anything like that anymore. So lots of fun changes on the horizon.
Agreed. Yeah, great overview of all those changes. Thank you so much, Russell.
Yep.
All right, well, that wraps it up for our very first conversation. Thank you so much, and please join us next time as we continue this discussion.